Okay, what I got here is a 1957, I believe, Hotpoint TV, 14-inch screen. You can see a little scuffing on this plastic, plexiglass or something. It's a glass between the picture tube. That's what we called them, instead of CRTs. And there's a glass between the two. I have repaired, serviced so many of them where I had to take the picture tube out and clean the picture tube and the inside of the glass because of the dirt that went in there. And yeah, they are do get pretty dirty, dusty, and it gives you the appearance that the tube is going bad when actually it's a lot of times just dirt. And if you're a smoker, it's even worse because that smoke will get in there. But okay, so this is I got it on my Lazy Susan here, so I can just turn it around real fast. We'll go around this way first. It's got some scratches and scuffs, but being 1957, it's being expected. It's pink. When I get this stuff off of there, I made a mistake in lubricated that Lazy Susan, and it was dumb. Oh well. Well, anyway, it's in good shape. It isn't dented or anything. Here's the cord. I'm thinking the cord's original, but the plug has been changed. So, yeah. What does that say there? Robinson TV, sales, rental, service, hobby, sporting goods. 608 Las Vegas Boulevard, Las Vegas, Nevada. I know servicemen do not like to repair to these because they're just, you'll see later. Knobs here, horizontal hold, the height, and it's in pencil. This kind of worn off. Vertical linearity. There you go, vertical linearity. On that one, height and horizontal hold. Your VHF. It's a model 17S301. Now we'll go back this way. And here we have the controls, which are turning. Your contrast, vertical, brightness, on and off volume. And then this is your channel selector. And then your tuning. So that was it. It's in pretty good shape. I'm going to take the back up over here and just... this is going to be a challenge to repair, and you'll see why. But might not be, if it can be repaired. I mean, if there's a bad CRT in there, or a flyback transformer, or a deflection yoke, it's kind of like... sure, some parts are out there, but just to find them and they're not likely. Let's see where else is one. Oh, I guess fits in a little tray, slot, so. How does that cord work? Oh, okay. And where else? I think this one's got to come out. And that should be it. Okay. with. Okay, there it is. Right there. This is fiberboard or whatever. It's not metal. Tube layout. I have a schematic for this, but I don't know what we're into. I hope you can see in there. It's not that, I mean, it's dusty. On this one, let me get my light. I gotta wait over here. I had to use this. I'm so used to using this. I hate the flashlights. Wow. Yeah, it's pretty dusty back in there. Looks like it's got all of the tubes in there. See this tuner. Yeah, the tuner seems to be okay. What is this? Looks like a tube shield. Huh, just laying on the bottom. Let me see what I'm looking at here. First of all, let me take a look at this. Flyback transformer. How do I get that open? Lay this down. Let's see how that looks. I mean, even it looks good. I don't see anything, any wax or anything melting, but that don't mean nothing. It actually looks really good in there. High voltage rectifier tubes. I think don't look too bad. There's the horizontal output. Damper tube. Tuner's tubes in there. Yep. So everything looks together. So the flyback transformer is good, and the CRT. Wait a minute. What the heck is that? Oh, I got a CMark on this reflection yoke. Let me get my glasses. Let me get my glasses. Hope not. Well, ain't doing no good. You know what? It looks like it arced on that reflection yoke. I don't know if it's. There's a sand-coated resistor back there that looked like it. That could have just been burnt. I don't know. Won't know until we get it out of there, because there's no way I'm going to power this up. Take a chance to mess up the flyback or something. When we know that every capacitor in here has got to be bad as far as the waxies and the filters, electrolytics. I don't know, this one might be a little different than what I'm thinking. What am I thinking? Okay, it's got a wave magnet on it. Not a wave magnet. Ion trap. On the tube, so when it's a GE, I was thinking the same thing. The picture tube is GE. I got the schematic for it. Like I said, this the photo fax, and it's calling for a 17. I don't get AV P4A. Or it could be a P4 and that's it. I got the pin out also. I downloaded that. So I want to check this CRT first. All of these tubes the heaters are in series to include the picture tube. Everything's in series, except for the high voltage rectifier. That's not. But all the other tubes and the CRT are in series. So if there's an open heater in there, well, that's going to kill it right off the bat. But we're going to first of all find out. I wonder if that comes off easy. Give you a slack in there. Yeah, let me see if we can get that off easily. There we go. Gonna give me a slack, okay. Looks like they got a jumper on there. I know the heaters are 1 and 12. One, two, three, four, five, six. What's this pin out on this thing? So that'll tell me. 1, 2, 3, 4, 5, 6. Okay. All right then. Let me get. So here's the magnet, the ion trap. You can move it back and forth. Boy, is that thing dirty. It's been probably sitting around for ages. But you can move it back and forth, and you can until you get to the brightest picture. All right, let me get this on pause, and I'll get my CRT tester since I got a pin out here. Unless I got an adapter for it, I don't know yet. G2 to 5. Check it again. F1 to 1, 2 to 2, K to 3, G1 to 4, and G2 to 5. Okay, got it. That change the settings when your guns have color. Well, we ain't got color. Okay, now let's see what we got here. Oh, we got CRT. We got CRT lightage. All right, here we go. The HK shorts. Around 6. We're just a little under 6.3. All right, we're gonna check for HK shorts. This is bad. G1 shorts is good and climbing. Cut off. Ooh, get the cutoff down. Emissions. We're going to have emissions, and it is good. See light test. It's staying in the good. It ain't going down. Usually to drop just a little bit. That seems like it's going to be a strong CRT. Cut off. No way I can't set the cut off. G1 shorts is very strong. Way it's pegging on it. And then the HK shorts. But that's make sure it's set at 6.3. It's a hair under 6.3 on my tester and the emission. Alrighty. Got the chassis out. Look at this. This resistor I was telling you is hitting the flexion yoke. Some idiot put it on there. Put the looks like friction tape on both ends, and then took a wire, wrapped it around the chassis, and just twisted it around to hold that. That's what I was thinking. It's just unbelievable. I don't know. The yoke is checks out good. This was hard to get off because like I said, you have to take the deflection yoke off, all the corresponding parts as far as the. I had to move a couple tubes to get this twisted out of there. Like I say, this Hotpoint and GEs back in the day weren't very. I don't think there ever was a serviceman alive like these things. So that's that. She was good. There's the output transformer, I said. And then you're just looking at the boards. Behind the boards are. So that one's open. Let me turn it back on. Okay, we're ready to test the CRT now. So we'll turn this filament down, voltage. Well, we'll keep it on 6, but we'll just keep this down. And alright, so we'll turn the power on. Everything stays the same as far as we got it on video. We have F1 and F2 adjustments. We got it on red or black and white. And you got green and blue. Cathode, G1 and G2 are set. Now, let's turn this G1 all the way down. And we're going to set the filament. So we set the filament at 6.3. I'll show you that. That's good right there. 6.3 volts for the heater, and let me see. And the filament, if you want to call it the filament, it is glowing in the back of the CRT, trust me. So we're going to do the heater and cathode short. Let me see. Let CRT warm up just a little bit back there. 6.3. I see it's okay. All right, the heater and cathode shorts. It's good. Let's see if she drops. Looks like it's maintaining. The grid 1 shorts. And that's pegging almost. If not. Now the cutoff. Now I got this. We're going to put it on 62 because it's calls for, 68, negative 68 on the bias. And you're going to see I have nothing. Okay, so I'm going to turn it back down. And I'm going to give it a negative 52 volts bias. Then we want to try to get it in the cutoff position. And there it is. Now we got the cutoff set. Now we can check for emissions. Emissions. It's reading good. So the tube is good. It's not ideal. Or what is it? About 16 volts less on the bias. So it's going to be, I think that's the contrast. Because what this is doing here, it's like the iris in a camera lens closing to let less light, from. So what it's telling me is the contrast is going to work, but it ain't going to be ideal. It should be on another 16 volts, more negative, to be ideal. But hey, it's going to work. It's really going to work. Go back to the cutoff, make sure it goes back in the same spot. It is. Try the G1 shorts again. HK shorts. And the film, let's see if we're back at, because we do got a load on it. We'll cut it down just a hair. That's cool enough. Yeah, that's good. The heater. They got HK. They call it filament, but then they got HK as heater. And cathode short G1 is excellent. And then a cutoff. We're on the money. Like I can turn it down, just go right in the middle. That's good enough. And then the emissions. It's reading strong at negative 52 volts on the bias, so it's going to be okay. But the, like I said, the contrast is not going to be ideal. But hey, for this being 1957. It's good. Now we're going to try a live test. It's probably going to drop. Let me see. I think the way that works is the filament voltage drops a couple of volts, I think. And by doing that, and if it moves down a little bit and stays, it's good, or if it stays. So we're going to hit a live test. It's going to move down. Look at that. It's going down. But it should come to a stop somewhere. It's going down. What kind of life we got? It's probably stopped right there. No, it's still dropping a hair, I think. I don't suspect it will go down to 13 volts. It's good, got good life at that level. Now it should climb back up, and it does. It's going back up. The needle's going back up. So this is not ideal, but it's good. So now, if you ever get one of these, it's like a vacuum tube tester. If you went through with the HK or the G1 and you had shorts, you do not want to continue on with further testing. You would have to go in there and try to rejuvenate, restore, remove G1 shorts. Or I wouldn't go rejuvenate, I would go with the auto restore, or manual 1 or manual 2 restore. Rejuvenate would be the last. Okay, I got the chassis here, and believe me, it's I don't think there's a service person around that likes working on these, because you got to take out all of the stuff on the yoke, the ion trap, and the couple other items in the deflection yoke, just to get this thing out. You got to be very careful not to cut a wire. And then getting this anode off the tube. I mean, really reaching in here and trying to get that is nightmare. But anyway, I did not check these tubes as far as emission. I just checked them for the heaters, and all were good. But because all 14, I think they were 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, and yeah, 14 tubes, and counting the CRT, are hooked up in series. Heaters are hooked up in series, so if one goes out, everything goes out. The only one that's not going to be in series is this high voltage rectifier, and that was a a 1X2A, and they got a 1X2B. It would work, but it shows weak. I did do an emission test on this one. And this tube here, this is the RF on this tuner. I think it's the RF tube. That's supposed to be I need a 3BC5, and they got a 3CB6. That's not a substitute or equivalent or anything. There's not no business in there, but I'm not worried about it at this time because it's an audio frequency tube. Nevertheless, the heater pinout would be the same. So it should power on, but it don't. There's an opening there. Okay, I'm gonna do something. I think it's a little premature, but it's fused. I found the bad fuse. This little fuse holder here, before I turn the power on. It's got a fuse back there and a fuse back there. Well, the fuse I was checking was a spare, but it ain't a spare because the one that was behind that is soldered in. So, has to be a reason for the fuse to blow, but we'll see. I'm going to turn it on, see if I had to put the CRT in, because naturally that's in series with all the other heaters or filaments, whatever, and I'm just going to see what happens. It's probably going to snap that fuse in a minute, but, or I should say second, but we'll see. I got it on amps. We'll see. Amps. It's not blowing it, and I got that 250 watt bulb in there. Did it blow it? Just give it a second, but I don't think I got the 250 watt bulb in there. I took the 60 watt out because it's, naturally. But wait a minute, do I got the switch on? I do. I got it on here at 117 volts. I'm not pulling no amps. It's got to pull a lot more amps than that. And it ain't that lighting up. Let me turn it off. And let me see. Let's turn this off. Let me check that fuse. It did not blow the fuse. Okay, this resistor is supposed to be 40. It should be about 41, I think it was, on the schematic. Let me see real fast. I gotta get these papers off here because I gotta bring the. Yeah. 41 ohm, 25 watts. It is a 25 watt. I can see 45 on there. So, as you can see, I hope you can see that. 1.299 meg and climbing. It'll go up to about 1.5 meg. So something, that resistor is really bad. So what I got here is two 20 ohms. That'd be 40. It's close enough at 25 watts. So we're going to put that in there. I'll get the CTR back in and jump that in there because I cut the one end off. And then so you could leave this on, and I'm sorry with the darkness now, but guys, I just wanted to see these tubes. See if they're cooled down. They're still pretty hot. I can't touch them. You can't touch that. What did I do with my dilly? Still at 128. It's cooling down, but I gotta see what the maximum temperature of those things can handle. I know those other resistors, metal oxide resistors, they can handle up to like 350 degrees or something. So I think these chassis mount ones will handle that. And it will get mounted correctly instead of hanging there by wires. Turkey guy. Person. Yeah. So I'm going to take this out of here. I'm going to start checking tubes on the, I'll do the ignition. I'm not going to go crazy and go into details. But I'm sure there's some weak or bad tubes or shorted grids. And fine filters. I guess I'll leave those cans in there. We'll see what we can do. But yeah, it's got, now we got power as far as that. So I'll be back when I do a lot of updating and whatnot. Yeah, I took this outside and I blew it off the best I could because it was getting so dirty inside this tube here. I wiped off the neck of that tube and cleaned the dust out of the inside. So this one up here is your vertical output, and this down here is a choke. It shows it in the line, or the filament line. And what they call in the, I call it flyback transformer, they're calling it a horizontal output, and that's your vertical output. And there's your choke, and naturally that's your audio output. So, okay. Turn it back on. Alright, so I've gotten this that far. Now it's just a matter of going around and start replacing stuff. I think our best thing to do is start checking tubes first and see what it's going to cost me to get this thing going. Now I know that the CRT is going to be okay, not perfect, but okay, acceptable. It's got a good chance of getting a raster and then picture pretty soon. I mean, it's all going to take time because there'll be a lot of stuff changing. Stuff's going to be out of value all over. Okay, I got, as you know, we didn't have power to the heaters, so we got that fixed by this fuse, and there was 41 ohm resistor reading. What was it? Close to 1.5 meg. So now I got a capacitor here putting parallel to get to 150 microfarad, because this capacitor is open, and as far as I can see from this schematic, I don't know if we can see that. Maybe I should turn the other one on, but I got this whole chain here of tubes, so we got that fixed. There was the resistor, and I'm jumping out, coming after the switch, and then the fuse is right there. So the fuse was out and that was out. Now we're going back to this way, and this 7.5 ohm resistor, it's a 15 watt. It's not open, but I think it's this one here I'm jumping out, or it's 150 microfarad going in for the rectifier diodes or whatever he could put in place, whoever put in place of that, and they didn't even put a drop-in resistor. I know it's gonna have it. I'm gonna take that out and put some diodes in there. That's just waiting for an accident to happen. So now, here we go. We're gonna turn it on. I think. Well, we gotta turn the thing on. There we go. See what kind of voltage we got. 117. Good. Okay. Hope you can see that too. Well, I can bring up the camera now. You see what I'm doing. Here's the fuse. I'm going to get the pointer now because I got damn power on. Except for the TV. There's a fuse that I jumped out to over here because that was soldered in. There's the resistor I'm bypassing with this one. And here's the caps that I'm replacing with this. It's hooked up and with it, but this is open. Pretty sure it is. Okay, so let me bring it up so we can see the bulb. I don't know if you can see it or not. Yeah, you should see it there. Alright, I'm going to turn it on. Let me get this on amps real fast. Amperes. Okay, it's okay. 9, it's 8, 7, it's dropping. Yeah. So it's lower than before. I got heater voltage. I'm not hearing any high voltage, but I'm going to see if we get anything. Smells that burnt in TV smell. Yeah, so you're not going to get the high voltage that's, it's not going to start arcing or anything. Because you just ain't got it there. I could check that. So I ain't getting an arc. I don't know if I want to do with this meter though, but I will. I will. DC volts. Crazy? Am I crazy? Ooh, I heard it arc. Stupid. I heard a little arky arc. I'm not going to do that. You know what I'm going to do? Hang on 1 minute. I'm going to get the meter. That's what I usually give my biopsy on the tube with. Let's play it smart and save the meter. How about that? This one will go up to 50,000 volts. We'll figure that out. These clips, I don't know if I'm so weak. Okay, here we go. We'll see. I hope you can see this meter. Yeah, we're getting a few little volts. That's 10, that's 5, 3. We're getting 3,000 volts. 1, 2, 3,000, yep. Okay, I'm at a stopping point at this point. So I evaluated the set. CRT is in pretty good condition. It's not, like I say, ideal. There's going to be a lack of contrast some. I'm going to get this unplugged. So we checked that. We checked all the heating, the filaments on the tubes, and eventually did a emission test on them all. And there's 3 tubes that need replaced. The ratio detector, RF tube, and the high voltage rectifier. So out of 14 tubes, actual vacuum tubes, 3 is not too bad. And one of them being because it was the wrong tube. So we got that. Then we just had to find out why we didn't have any tubes weren't glowing. It didn't have no voltage. It was just didn't power on. And we found the fuse had been blown, and the fuse that they have is a 2 amp, which was blown. And the one they had in there as a spare is a 3 amp. I'm not using that, so I used one out of my stock. This sand-coated wire wound resistor was reading closer to 1.5 meg, and it's supposed to be a 40. Well, this one should have been a 45, I think, ohm at 25 watts. So bypass that. I got the filaments working all throughout the set, so we repaired that. And then I did find this capacitor here open, and I put in a well, 100 and 147 is what I had. Try to get 150 microfarad and jump this one out. We got 3,000 volts coming out of our anode cord here, so it's getting there. It's just I gotta wait for parts. It's gonna be a part 1. It could be definitely part 2 and 3, maybe part 4. I'm not sure, because once I get this stuff together, you know, there's going to be other audio or especially video issues where you have to fix, troubleshoot, repair. But yeah, so this is part 1. That's it. I'll see you again when I start part 2.